In this session, let's discuss about how to find Norton equivalent impedance Zn of a circuit if the circuit contains only independent sources or the circuit with dependent and or independent sources. So first of all, let's consider circuit with only independent sources. Let's consider a simple example like this. In this circuit, only one voltage source is available, that is independent voltage source. So in order to obtain Norton equivalent impedance, we need to see the impedance through the open circuit terminal while making all sources to zero. That is replacing all sources with their internal impedance. In this case, only one voltage source is available. The internal impedance of voltage source is zero. Therefore, we can replace voltage source by short circuit. So, considering this example, the impedance seen through the open circuit terminal is like this. So, Rn is equal to this R is in series with this parallel combination. So, R plus R by 2, which gives 3R by 2. In general, we can say like this. In order to obtain Norton equivalent impedance, we need to find the impedance of the circuit looking through the open circuit terminal A and B, keeping all independent sources to zero. We know voltage source is made to zero by short circuiting and current source is made to zero by open circuiting its terminals. In second case, that is circuit with the dependent and or independent sources, there are two methods in order to find out Norton equivalent impedance. That is method 1 and method 2. In method 1, in order to obtain Zn, we need to follow the following steps. So first step is find open circuit voltage VOC across the open circuit terminals A and B by conventional method. And second step is we need to short circuit the open circuit terminal and find the short circuit current ISC through the short circuit terminal. So this is nothing but Norton equivalent current, that is IN. And the third step is finding out Norton equivalent impedance or Norton equivalent resistance using this expression VOC by ISC. In method 2, we need to follow the following steps. In method 2, we need to apply a DC voltage source VDC at the open circuit terminals A and B, keeping all other independent sources to zero. Due to the application of VDC at the open circuit terminals, a current will flow to the circuit from the source. That current is IDC. So, due to VDC across A and B, a DC driving current IDC will flow to the circuit. So, the third step is calculate Rn. We can find out Rn by using this equation VDC by IDC. Summarizing, in method 1, first of all, we need to find out the open circuit voltage across the terminals A and B. Then we need to short circuit that two terminals and we need to measure the short circuit current ISC or IN. Then finally, we need to find out Norton equivalent resistance Rn or Norton equivalent impedance Zn by using the expression VOC by ISC. In method 2, we need to connect a DC voltage source across the open circuit terminals A and B, keeping all other independent sources to zero. That will send a current to the circuit, that is IDC. Then we can calculate Rn or Zn as VDC by IDC. In this way, we can find out Norton equivalent impedance or resistance if the circuit contains dependent sources along with independent sources.